part 3 of exploring the Lorentz transformation. Here are equations back again, and I've changed them back to A and B for Bob and Alice because we're going to write a new version of them up here, and it will be easier to see what's going on if we're thinking about Alice and Bob again. But of course, we can think about the rest frame and the moving frame, or lab frame and rocket frame, if you want to think about it that way, where Alice in this case would be the rest frame or the lab frame. Bob would be in the rocket frame, that is moving with respect to the lab with positive velocity v. And the question is here, really two-part question, essentially the same question, just asked in two different ways. First one is, what happens in terms of Bob looking at Alice? Bob thinks he's stationary, that's his perception, and it's Alice who's moving with constant velocity, but in the opposite direction, in the negative x direction. What would the equations look like in that case? Another way to say that is, what if we just turn Bob around and Bob goes in the negative x direction at velocity v? Then what would it be? But let's ask it in terms of the first version, in terms of, okay, now let's look at it from Bob's perspective. He's seeing Alice move with velocity negative v, essentially in the negative x direction, or we could say with velocity v in the negative x direction. And the key here is because, we could go back and say, oh, do we have to do that derivation again and go through and change any time the velocity appears, turn it into a negative sign and then see negative v and see what happens? And fortunately, the answer is no. Even if it was yes, we probably wouldn't go through it all again. We just give you the result. But here's our basic equations that were derived on the assumption that the rocket frame, the moving frame, is going with velocity v in the positive x direction. If we have a velocity v in the negative x direction, all we have to do is change the sign any place we see v appear in our equations. Because v is assumed to be a positive quantity here, so if we're just changing direction to the negative direction, it just becomes a negative v. And again, we'll assume the actual value of v here is positive, so by putting a negative sign in, that will just change the direction. And the other factor we have to remember is, well, v also is in gamma. So the good news there, though, is gamma, of course, square root of 1 minus v squared over c squared. V squared saves us in this case because, of course, if you take a negative number and square it, it turns into a positive number. So that whether v is negative or positive, gamma has the same value. Gamma does not change. So we don't have to worry about gamma. And the only changes that are made here are in these two plus signs. Instead of having a plus v over c squared and a plus v, I have a negative v over c squared and a negative v, or minus v in each case. So we can write it like this. From Bob's perspective, we'd say, okay, TB for Bob is gamma TA minus v over c squared xa, and xb for Bob is gamma times xa minus v t a, like that. In other words, given x and t values in Alice's frame of reference, as she measures them, then we can figure out what the values would be in Bob's frame of reference, just by putting the minus signs in there. So that gives us a sense of how we can go back and forth very easily. And it's probably useful to memorize one form of these, and perhaps if you like to use the terminology lab and rocket, because it's very visual that way. So if you think, okay, I'm going to have a rocket moving to the right in the positive x direction, and so therefore the b's here would be the lab quantities, and the a's would be, the b's here would be the rocket quantities, and the a's would be the lab quantities, if you want to think about that, or the rest frame quantities and the moving quantities. This assumes motion to the right, positive x direction. This version down here essentially says, now the b's are the lab frame of reference, the rest frame in this sense, because now Bob, sitting in his spaceship, is assuming that from his perspective, he's in the rest frame and the lab frame. And it's Alice moving, whether she's in a ship or not, she's moving to the left there. And therefore, you get the negative signs in there. Otherwise, it's the same form there. So as we proceed, we will explore more of the implications of this. This week we'll do a little bit more quantitatively, again with leading clocks lag, but then as we move forward, we'll start actually reintroducing space-time diagrams, and not this week, but next week, and then also getting into some of the paradoxes involved with the special theory of relativity that the concepts and equations we've developed so far lead us into, and so we need to figure out some of those things. But before we get into that, we have a few more things to do for this week.